Okay, I want to take you through the actual practice quiz. Now, this packet contains a lot more practice problems that I do want you to make sure you look at the answers. I'll have a PDF copy of all the answers to this page, the trig and review. Make sure you know how to set up the 6 trig ratios given a right triangle. So there's plenty of practice problems. I will allow you to keep it where there's a radical in the bottom. Now, I'll show the proper technique, but there's nothing wrong with having a radical in the bottom, at least at this level. Okay, so we had the right triangle trig review paper. There were some more problems where, again, just go through and make sure you know how to set up where you can find the missing pieces of a right triangle. Okay, so make sure your answers agree with mine. More practice problems here. Okay, so if you have any questions, just let me know. So that was the week in review. And so I want to take you through this page right here. This is what you can expect on your quiz, your trig quiz, your first trig quiz, which is going to be on just setting up the ratios and some basic right triangle trig. So first problem, I give you a right triangle. I give you 2 out of the 3 pieces. You need, in this case, to find the hypotenuse. Okay, so let's just ask the calculator 7 squared, because that's a leg, plus the other leg squared. That's going to give us a 625. C is going to be the square root of this. So second x squared, 625, and you're going to see that it's a 25. Okay, so the missing side, the hypotenuse, we now know is a 25. So you definitely will need to use the Pythagorean theorem to find the missing side of your right triangle. And now the next thing you want to do is look where that theta symbol is. Okay, so it's so important that you're looking at the correct angle when you're setting up these ratios. So the side opposite this angle is the 24. Okay, the side next to it that's not the hypotenuse is the adjacent side, and the hypotenuse is always the side opposite to 90-degree angle. So in this case, 25 is the hypotenuse. Okay, so then pretty easy for you to, once you have your right triangle filled out, it's very easy to be able to get these 6 trig ratios. So in this case, my opposite side is a 24 over the hypotenuse, which is 25. You get a point for the sine. You flip that around, you'll get a point for the cosecant. Okay? Cosine is defined as the adjacent side over the hypotenuse. Well, for this triangle, the adjacent side is a 7, hypotenuse is a 25. I flip it for the secant, where I'm comparing the hypotenuse to the adjacent side. Okay, and finally, tangent, the TOA part, is the opposite over the adjacent. Cotangent, flip it. And that's all you're doing. We could easily find out what theta is, okay? We could ask any of these to tell us what that angle measurement is, but that's not what I'm asking. So you will get 6 points on your quiz if you can quickly fill out the 6 ratios. Now for this one, I don't have the right triangle, so I want you to draw a right triangle. So I give you one of it. So I'm basically telling you that the secant is 8 out of 3. Well, that automatically forces the cosine to be a 3 out of 8. Okay, so make a generic right triangle. Put your theta in one of the acute angles. I'm going to put it down here. So if I have my theta symbol here, this is my adjacent side, this is my opposite side, and there's my hypotenuse. Oops, hypotenuse. So I know my adjacent side is a 3. My hypotenuse is going to be the 8. Okay, that's right. That's clear. There you go. So the last thing I need to do before I fill out the rest of my trig ratios, I need to just calculate what the opposite side is. So I'm going to use Pythagorean theorem. This time I tell you what C is. So it's going to be 8 squared minus my 1 leg squared. So in this case, it's going to be really a 64 minus 9, which is 55. We take the square root of 55, just leave it as root 55. Okay, I don't need a decimal for these, so we want to use radical form. Okay, so should be easy from here on out. So look at your theta, opposite over hypotenuse, root 55 over an 8. Okay, flip it and you get another point. Now I will show you, I will take the time to rationalize the denominator. I would multiply both top and bottom by root 55. So here's an equivalent answer that your trig teachers may make you write it this way, but really 8 over the square root of 55, that's fine. The calculator can calculate that very easily. So I really don't have a problem with a radical in the denominator. The tangent is going to be root 55, which is my opposite side from theta, over my adjacent side. And if I flip it, I have the cotangent. So I'll just again write it this way for some students that were practicing rationalizing a denominator. Okay, so that's 12 points right there for your quiz. This next section should literally take you a couple seconds. You do need to make sure, double check to make sure when you pick up your calculator for this quiz that degrees is highlighted. Okay, so you reset your calculator. So if I quickly reset my calculator, you're going to see that by default, when I hit the mode, I'm back to radians. So you need to make sure you toggle 2 degrees, hit enter. Now we have our calculator set up for degree mode. So this section, all we're doing is typing in, especially if it's the sine, cosine, tangent. Don't get those wrong. So sine of a 44, I hit the sine button. I'll show that. Right there is my sine button, and I type in 44, and I want you to round to 4 decimal places, just like you did for the big idea assignment. So let's do 0.694, and that 6 should become a 7, okay? Because next to the 6, we have a number 5 or greater, okay? So just make sure you round properly. So I'm going to do the cosine of 85. That's easy. Okay, and you get 0.0872. Okay, now when you're doing these, just try to get a visual. Okay, 85 is a pretty big angle. Okay, it's close to our right. So if you try to visualize a 85-degree angle, almost perpendicular, when you compare the adjacent side to hypotenuse, you're going to have a small number over a big number. That's why this ratio should make sense to you for that particular angle. Okay, so then we go to tan. So tan of a 20-degree angle. Again, tan is a pretty, 20 degrees a small angle. So when I'm comparing the opposite, my opposite side is going to be a lot smaller than my adjacent side. So it should make sense that we are getting a pretty small number. So a small number over a bigger number. Think of a test grade. You only earn 36%. So it's 0.36. And I'm going to round this to 40. 40. Okay, so that 9 really becomes a 10, which would bump this up to a 4. 0.3640 is the proper way of rounding that. Okay, now the rest of these, you will not have this particular key on our calculator. We don't have a cosecant button, okay? But we do have the sine button. And so, and again, now here, technically, I think on your quiz, I'll make sure that these are part of a, a regular angle less than 180, okay? So technically for a right triangle, these should be acute angles, but you're gonna see later on that I can take the sine of 317 degrees, okay? It's a negative angle. We didn't even talk about negative angles, so this was a pretty poor example, but you get the idea. If it's cosecant, you're going to do the sine, but then you must hit x to -1, okay? So I will not put a -1 on your quiz, but hopefully you get the idea that how you type these into your calculator, okay? So the rest of these, this is how it's going to be. The secant, you need to type in the cosine. So the cosine is adjacent over the hypotenuse. So we're going to first figure out what that would be, and it's 0.34 or 0.3420, but that's not what you want to write down in your paper. We want to compare the hypotenuse to the adjacent. Hypotenuse is a bigger side. So when I flip this around, that's that x to the -1 button. Okay. So after you type in the cosine of 70, hit this x to the -1. It's right there. And then hit enter. And then it should make sense that this is 2.9 2, and we'll keep it 3.8. Okay, 4 decimal places. Okay, so almost triple. The hypotenuse is almost triple the size of the adjacent side. So that's how you want to think about it. And then finally, the tangent. I'm going to do the tan of 67. Again, tan compares the opposite over the adjacent. And so if you think of a 67-degree angle, it's a pretty big angle. So when I hit the tan of this, it makes sense that the opposite side would be more than double the adjacent if you actually drew a right triangle with that measurement. But I want to compare the adjacent, because it's cotangent, to the opposite. So again, I flip it. So I just hit this x to the -1, and I copy down 0.424, and I'm going to round that to a 5. So this 4 technically should become a 5 because that 7 is more than 5. I round up. Okay, so hopefully that section, again, disregard this one. I won't have a big angle. We have yet to talk about angles like this. So we'll get to that later on, but expect something like the cosecant of 50 degrees. So if I give you cosecant of 50 degrees, you're going to do the sine of 50, then flip it. Okay, the x to the -1. Let's take a look at this last page. So once you do your calculator work, then you're going to see I'm going to give you 2 problems where I want you to be able to use trig at least one time. Now, if you choose to use trig more than one time per problem, that's fine. But I really only need to use trig one time to be able to solve these missing pieces. So for example, for number 9, I don't need trig to know what angle B is. Okay, I tell you angle A is 50, 90 minus 50, that forces B to be 40 degrees. Okay, now I need trig now based on the fact that I don't know what B is. I don't know the hypotenuse, but I do know A is 15. Okay, so it is your choice how you want to, which trig ratio you want to use. If I use this 50 degrees, I need to make sure I use a trig ratio that's involved with the opposite. Okay, I must have opposite, but I could do tan. Tan of 50 is 15 over B. I could do sine. Sine of 50 is 15 over C. So it all depends on what you want to solve for. Now, if you don't want to have a harder problem to solve, then technically finding angle B using this angle. So if we use the fact that this is a 40 degrees, I'll show you this technique. And again, this is not the only way, but it's probably the easiest way of solving if you would actually do, say, the tan of 40 degrees. Okay, so now I'm referring to this angle right here, angle B, which we said was 40 degrees, is defined as the opposite, which we don't know, over the adjacent, which we do know. Okay, adjacent next to angle B is at 15. So then it's really easy. And I'll show a different way to solve this. So if you didn't set it up using the tan, let's first get this answer. Tan of 40, where it's comparing the opposite to adjacent. You do the tan of that, and then you multiply to solve for B. I just have to undo division by multiplying. So I multiply by 15, and I get 12.59. Now, and here I tell you to round to tenths, so I guess I should round to tenths. Better do my direction, so I'll say 12.6. Okay, so there's 12.6. Now, let's just say you tried to do something with this 50, okay? So let's say, hey, I wanted to do the sine of 50. So if you would have done the sine of 50, you would be finding C, okay? So because sine is defined as 15, the opposite side, which I know is a 15, over the hypotenuse, which I don't know. So just keep in mind. Okay, now remember, to solve this, we really need to get rid of the C in the bottom. So technically, and think about cross multiplying. So you have sine of 50 times C equals 15. So remember, to solve for C, I'm going to divide. So this one's a little bit more tricky to solve if you're going to do it this way. So all I need to do is ask my calculator. Let's clear this. It's 15 divided by the sine of 50 degrees. And it's going to tell me 19.6. So about 19.6. Now, again, we didn't need to do trig for that one. So, just let me quickly show you this yet on the calculator. We use trig to find side B. So if we knew side B is 12.6, we can square that plus the 15 squared. We'll get that. That's what C squared actually equals. And so to find C, I take the square root of that answer, and you're going to see we get 19.6. The same thing that we got using trig, but technically we only need to use trig one time to find all the missing pieces of a right triangle. Okay, so let's take a look at number 10. For number 10, we can find side A without trig. Okay, use the Pythagorean theorem. So I'll set this up. I don't know what A is, but I do know that B is an 8, and I know my longest side is a 9, so 9 squared. So all I'm going to do to solve this is I'm going to type in 9 squared minus my 8 squared, okay, because I have to subtract that. That's what A squared equals. So A squared equals 17. This isn't going to work out. I don't want a decimal. Actually, I do want it. That's right, because we do need we're not setting up the trig ratio. For this, we do want to ask the calculator, hey, calculator, what's the square root of 17? And it says, hey, it's about 4.1. Okay, so A is 4.1. 4.1 inches, whatever you're dealing with. So in this case, I don't have a unit, but 4.1 units. Now, here's where we need to use trig at least one. We could use trig to find A, we could use trig to find B, but technically you only need it one time. So if I'm going to use angle A, I need you to realize that angle A, just based on, and I would use the two sides that were given. This one we rounded, so that's going to have a impact on this angle measurement. It's probably better to use the 8 and the 9. So from angle A, my adjacent side is 8. My hypotenuse is 9. So that is the cosine. So cosine of whatever this angle measurement is based on having an adjacent side of 8 and a hypotenuse of 9. So remember, to solve for A, that's where we hit second cosine. Okay, so when we use our calculator, we're going to hit the blue button, then cosine, and then it's just simply going to look. It's going to look up that ratio of 8 over 9, and it's going to tell what the angle is. So angle, so let me just show you this on the calculator. Second, and then cosine, which is right here, and it's 8 divided by 9. Okay, back in my day, not that you care about how hard I had to work back in my day looking up that decimal, just to know that, hey, that's a 27.3 degree angle. Okay, so now B, now since you're, hopefully you realize B can just be 90 minus the 27.3, but I am going to show you trig just to, in case someone set up a trig ratio to find B, well, at least make sure you know where it's coming from. So if you did B, which in this case, I would use the opposite and the hypotenuse. So opposite of B, that's really the sine of B. The sine of B is really going to be 8 over 9. Now notice I'm going to get that same answer of 62.7 degrees when I hit second sine. So second sine, and I'm going to type in 8 over 9. It's going to tell me the 62.7. That's what I already had. Okay, so again, it's can't hurt to double check, but technically trig only needs to be used one time, but I'm showing it twice here. Okay, showed it for the angle A and I showed it for angle B. But with that said, it's very easy. Once you know one of the angles, 90 minus the acute angle, you'll get the other one. Okay, last two application problems will be on your test. So try to draw a picture. Okay, try to get a visual. This will be a right triangle that you're dealing with. We have a 20-foot ramp. There's my 20-foot ramp. Okay, and we're told that it is 3.5 the platform. So this part right here is 3.5 feet off the ground, and we want to know this angle. Okay, so this is pretty easy to be able to solve. That's what the visual is. And so from this angle, from the angle of elevation, I know the opposite and I know my hypotenuse. So just based on the given numbers, yeah, we could use the Pythagorean theorem. I don't really care about this length. So to find theta, that missing angle, all I need to do is the sine. So the sine of this angle of elevation is defined as 3.5, my opposite side over 20. And just remember, whenever you're finding an angle, blue button sine, so that's second sine 3.5 divided by 20. And let's quickly ask the calculator for this. Second sine, and it's the 3.5 divided by 20. It looks that up, and then you know, hey, that angle is about 10.1 degrees. Okay. And hopefully, if it's a ramp, you know it can't be that steep. Okay. So, should make sense in the context of this problem. Okay. Last application. What are we dealing with? We're dealing with a television camera at ground level is filming the liftoff of a space shuttle at a point 750 meters from the launch pad. So there's my rocket. That's a horrible rocket, but there's my rocket. USA. There we go. That's horrible. I'm sure you can do a much better job, but we know we're 750 meters away from this launch pad. Okay. And then we're told that the angle of elevation to, let's see, when it is tilted at a camera elevation, what is out? So this already took off. So this somewhere in the air, and we want to know, excuse me, we want to know how high off the ground this is. Okay. This is 58 degrees. Okay. So all we have to do to find what X is, this height off the ground. So again, visualize this already taken off. Then we get locked in an angle to that where the rocket is. And so opposite over the adjacent is tangent. So if I ask the calculator, hey, what's the tan of a 58-degree angle? We are going to easily be able to solve for X. Okay, so to solve for X, all I need to do is type in the tan of 58 degrees, hit enter. Okay, it's 1.6 something, and I just need to multiply by 750. So we're going to see that, hey, this is about 1200 point, and I'll round to 3 meters off the ground. Okay, that's all we have to do for that problem. Okay, so that took 25 minutes. Please check the rest of this out then. So there's another part. Again, get these answers. So this is not going to be on the quiz, but I still want you to, I'm giving you all week to get this done. So this is going to start reviewing some key concepts for our final. Everyone should remember how to do logarithms. We should remember how to do that synthetic substitution. So instead of directly replacing this x with a -2, I know the answer is going to be 5. Okay, whatever the remainder is the answer if you would directly substitute whatever this number is. So just go through that, practice that the progress or the process of going through synthetic division. Okay, this we should know, the rise and fall. I know it's in opposite directions because it's an odd exponent. Okay, I also know it's going to fall like this because there's a negative number in front. So when I'm looking at end behavior, all I'm concerned with is the leading coefficient and the degree of the polynomial. Okay, so again, you should be able to reason out, and if you don't understand where something comes from, you need to ask. This is recent memory, this type of problem where we factor. Some of you are still struggling a little bit with factoring, and then once everything's factored, cross out what's in common. This one's rules of exponents. This one's a classic. Here are the 3 x-intercepts. Here are my x-intercepts. Now write a rule for it. So these are the intercepts. These are my factors. I can do FOIL. Can take this times this, do FOIL properly, distribute the x, and I get my rule. And then I end this with some more. I'm not going to go over this now, but you can see the answers. If you disagree with any of my answers, simply ask. So some more practice with solving missing pieces of right triangles. And then I end with 2 more applications. So again, make sure you know the setup for the application. So you can set up the problem and try a trig ratio. Anytime you try a trig ratio and you have 2 unknowns, you can't solve it. So pick something else. So I promise you there's enough information with these word problems where you'll be able to set up a trig ratio and find the one missing component to your trig ratio. Okay, so these are 2 good problems that you should be able to make sense of. Okay, now it's 27 minutes. Take care.